Hello everyone. In this video we are going to be looking at the solutions to Physics 1 right-hand rule practice problems 2. These right-hand rule problems are going to deal with our second right-hand rule. So just a quick review of that rule. I know that with the right-hand rule, my fingers represent the direction of the current. My thumb represents the direction of the force, and my palm represents the direction of the magnetic field. So the magnetic field is coming straight out of my palm. And remember, for these problems, I am going to be using my left hand because the camera acts as a mirror. So I need to show you the reverse of what it would look like in person. And so you would always want to use your right hand because they are the right hand rules. But just because I'm doing this to a camera, I am going to be using my left hand. So let's take a look at the first problem. I have a force oriented in the positive x direction, and I have a current oriented in the negative y direction. So if I have to stand up for this, if I orient my fingers, which represent the current, going straight downward, my thumb, which is the force, needs to be oriented to the right. So I have to turn my hand like this. So now my fingers, which represent the current, are pointing straight down. My thumb, which represents the force, is pointing to the right or in the positive x direction. My palm, which represents the magnetic field, is pointing toward the screen. So that is in the negative z direction. And we always denote the negative z direction with an x. The next one wants us to find the velocity. That would be our third right-hand rule. The third right-hand rule is very similar to the second right-hand rule. My thumb is still the force. My palm is still the magnetic field, but my fingers now become the direction of the velocity or the direction of the motion of the particle. So if I want to orient my hand where the force and the magnetic field are, my force is in the negative z direction, which means that my thumb needs to point inward to the screen. I need to stand up for this one. So my thumb needs to point into the screen. That's the negative z direction. My palm wants to be facing upward because that's the direction of the magnetic field, is in the upward direction. And we can see that my fingers, which represent my velocity, are pointing toward the left or in the negative x direction. So my velocity vector is in the negative x direction. In this problem, we are given the direction of the magnetic field and the direction of the current. We are being asked to find the direction of the force. So my magnetic field is pointing in the upward direction, and my current is pointing out of the page or in the positive z direction. So again, I need to stand up for this. But if I want to orient my fingers so they're pointing away from the screen, so here are my fingers down here, they're going to point away from the screen. My palm is facing upward. My thumb is the direction of the force, and that is going in the negative x direction or to the left. So my force is going to the left or the negative x direction. In this example, we are given the force, which is going in the negative x direction. The magnetic field is going into the negative z direction or into the page, and we are being asked to find the velocity. So because the magnetic field is going into the page or in the negative z direction, my palm wants to be facing toward the page. My thumb wants to be facing to the left or in the negative x direction, and my fingers represent the direction of the velocity. So my fingers are pointing to the north or in the positive y direction. Part E gives us the force in the negative y direction, the velocity in the positive x direction, and asks us to find the direction of the magnetic field. So if the force is going in the negative z direction, my thumb needs to be pointing downward. My fingers, which represent the velocity, need to be pointing in the positive x direction. So I need to turn my hand around. So my thumb is now pointing downward. My fingers are now pointing to the right. My palm is facing away from the screen. So if there was an arrow coming out of my palm, it would be pointed away from the screen, which means that my magnetic field is going to be in the positive Z direction or out of the screen. Part F gives us the direction of the magnetic field, which is in the positive Z direction. Gives us the direction of the force, which is in the positive X direction, and is asking us to find the direction of the current. So if the magnetic field is in the positive Z direction, my palm wants to face away from the screen. So my palm is facing away from the screen. My thumb wants to be pointing in the positive X direction or to the right. And my fingers are showing the direction of the current, which is in the positive Y direction or upward. And you can tell that because I have all 4 of my fingers pointing upward and not just one of them, which means I do want to keep my job still. The next diagram shows us the direction of the magnetic field in the negative Z direction. Shows us the direction of the current, which is in the positive Y direction, and is asking us to find the direction of the force. So because the magnetic field is in the negative Z direction, my palm wants to be facing toward the screen. My fingers are the direction of the current, so those are pointing upward, and my thumb is going to give me the direction of the force. So my thumb is pointing to the left or in the negative X direction. And I've done, 2 of these in a row without having to contort myself really bad. So now things are going well so far. Part H gives us the direction of the force in the negative X direction. Gives us the direction of the current in the negative Y direction, and is asking us to find the direction of the magnetic field. So my thumb is the force that wants to be pointing toward the left or in the negative X direction. My fingers, which represent the direction of the current, want to be pointing downward in the negative Y direction, and my palm is going to be the direction of the magnetic field. We can see that my palm is facing away from the screen, which means if there was an arrow coming out of my palm, it would be moving away from the screen toward me, which would make that the positive Z direction. So the magnetic field is in the positive Z direction. Part I gives us the direction of the force in the positive Z direction, gives me the direction of the current in the negative Y direction, and is asking for the direction of the magnetic field. So the current is moving in the negative Y direction or downward, so my fingers need to be pointed downward. My thumb is the force, and that wants to be pointed away from the screen. So my thumb is now pointed toward my face, away from the screen, which means that my palm is now pointing toward the right or in the positive X direction. So my magnetic field is in the positive X direction. The next part is giving us the direction of the force, which is in the negative Z direction. We are given the direction of the magnetic field in the negative Y direction, and we are being asked to find the direction of the current. So if the force is in the negative Z direction, my thumb wants to be pointing towards the screen. So my thumb is pointing toward the screen. My palm is facing downward because that is the direction of my magnetic field. So if there's an arrow coming out of my palm, it would be pointing downward. And my fingers here represent the current, and my fingers are pointing in the positive X direction or to the right. So the current is to the right or in the positive X direction. Part K gives us the direction of the force in the positive Y direction, gives us the direction of the current in the positive X direction, and is asking us to find the direction of the magnetic field. So if the force is pointing upward or in the positive Y direction, my thumb wants to be facing upward. My fingers, which give me the direction of the current, want to be facing to the right or the positive X direction. So now my thumb is pointing upward. My fingers, which are the direction of the current, are pointing toward the right. My palm is the direction of the magnetic field, and my palm is facing toward the screen. So if I had an arrow coming straight out of my palm, it would be pointing toward the screen or into the page. So the magnetic field is in the negative x direction. And our last problem gives us the direction of the velocity in the upward or positive y direction, gives us the direction of the magnetic field in the positive z direction, and is asking us to find the direction of the force. So again, my fingers represent the direction of the velocity. That is going straight up. The magnetic field is in the positive z direction, which means it is coming out of the page. So my palm wants to be facing toward me. And my thumb is the direction of the force. And my thumb is pointing toward the right or the positive x direction. So my force is in the positive x direction. One last thing I want to say about these problems, remember that we have three variables, whether we're dealing with the second or third right-hand rule. For the second right-hand rule, we have the force, the magnetic field, and the current. For the third right-hand rule, we have the force, the magnetic field, and the velocity. We have three axes that we are working with, the x-axis, the y-axis, and the z-axis. Only one of each of those factors can be on any given axis. So if I have the force on the x-axis and the velocity on the y-axis, that means that my magnetic field has to be on the z-axis. I can only have one of those components on any axis. So all three axes need to have one. So on this problem, I know that the magnetic field was in the z-axis. I know that the velocity was in the y-axis. Automatically, I know that my force needs to be on the x-axis. I just need to use the right-hand rule to determine if it's on the positive or negative direction. So that's just a little tip for helping us solve these problems. It kind of simplifies it and makes them a little bit easier to figure out.